All right, back page, we have a couple of examples, and I want to use tables when I'm doing this so that you can kind of see how the graph ends up looking very close to our x squared, okay? So we're gonna graph each function and identify its characteristics. All right. F of x equals 3x to the 6th. I'm going to use a table here. Okay, and so xy, and if I use -2, -1, 0, 1, 2, that will be a good amount of points to plug in and see what happens. All right. So what if I plugged in -2 to the 6th power? And then times it by 3. That's going to be a huge number. That's going to go way off our graph, okay? So that's essentially why this ends up looking very similar to an x squared. Okay, so -2 and 2 are going to go way off the graph. Let's try -1. This would be 3 times -1 to the 6th. And -1 to the 6th is positive, so 3 times 1, 3. Okay? Then we're at 0, 0. And if I plug in 1, I'm going to get 3 again. Okay? So these go off really high at -2 and 2. But we have 3 nice points to put on the graph, so let's graph that. 0, 0, 1, 3, and -1, 3. Okay? And then it's going to go really high to 2. So it's obviously not asymptotic. It would go even higher at 3. But this is skinnier than a x squared would be. Well, and we have a stretch, so that too. Okay? Domain, all real. Range, y is greater than or equal to 0. Our x-intercept, well, if we have 0, 0 as one intercept, it's going to be the other intercept also. And actually, for these power functions that don't have anything added or subtracted to them, they should all go through the origin. Okay? So, we're decreasing at first and then increasing. Down the hill, then up the hill, from left to right. So our increasing interval is 0, infinity. Decreasing is -infinity to 0. And our symmetry, well, you could look at the graph, but even if you don't have the graph, we just said that an even function is symmetric about the y-axis. It has y-axis symmetry. All right, discontinuities. Is there anywhere where you have to pick your pencil up and start your graph again if you're tracing it? No, there's none. All right. And in behavior, without even looking at the graph, because eventually you won't even be given the graph, we said an even positive coefficient should be pointing up and up, left to right. Okay, so without even looking at the graph, eventually you're going to have to get there. You're going to have to be able to say this without seeing a graph. So as x approaches infinity, y approaches infinity. Oops, I forgot my arrow. There we go. And as x approaches -infinity, y approaches -infinity, positive infinity. Oops. So they're pointing up and up. Sorry for my mess ups. All right. Next. So f of x equals -2x to the 5th. So again, if I plugged in 2 here, or -2, that would be a very big number. Especially when you multiply it by 2. So let's just try our xy table with -1, 0, and 1. Okay, So I'll do -1, 0, 1. Okay, so if I plug in -1, I have -2 times -1 to the 5th. That's -2 times a negative to the odd exponent is going to end up negative, -1, which is 2. Okay, then if I plug in 0, I'm at 0. And if I plug in 1, -2 times 1 to the 5th is -2 times +1, -2. All right, so I have those 3 points to put together. Okay. -1, 2 is up here. Then I have origin. And then I have 1, -2. Remember, if I wanted 2, it would go really high. So don't cross that x equals -2 and x equals 2. You're really kind of like approaching it. Because that would actually go up to 64. Yeah, and down to 64, okay? So skinny. Getting close to 2 but not crossing on our graph. All right, domain. Again, all real. And range is all real. It's not greater than or equal to 0. It's a little different than our even functions. X and y intercepts are both at 0. Okay. And if we read this left to right, I'm going down the whole time. All right, and you don't need to include your point of inflection. There's no increasing interval, and it's going down the whole time. So you can just say -infinity to infinity. Decreasing the whole time. Symmetry is at the origin, because I have an odd function. And discontinuities, again, there's none here. No gaps or jumps in my graph, nothing removed. All right, and so in behavior, we have a negative and an odd, a negative coefficient and an odd. So that would be the opposite of a positive odd, obviously. So it's going to be pointing up on the left and pointing down on the right. Okay, so as x approaches infinity, that's my right side. Y approaches -infinity. And as x approaches -infinity, that's my left, y approaches infinity. Okay, and again, I know you can look at the graph, but you're going to have to be able to say this without a visual eventually. All right, oh, and then I always forget, but these really should technically all be f of x's. As we move on in math, we really use function notation pretty much from here on out. Okay, but as long as you understand that, it's all good. All right, last one. So f of x equals -1/2 x to the 4th. Okay, and I'm going to put in for the same reason, just -1, 0, and 1, the same x's. All right, so for -1, I'll have -1/2 times -1 to the 4th, which is just 1. So that'll be -1/2. Okay, 0, 0, and 1 is also -1/2. Okay, so this is a vertical compression here. So it's going to go a little bit wider than we were expecting, or than we did before. Okay, so we have 0, 0. And -1, -1/2. It's down there. Then 1, 1/2. Okay, so see it's opening a little bit wider. Than our number 1 opened. Okay. All right, so your domain, all real, and now this is a negative even, so our range has flipped. Its y is less than or equal to 0. All right, the x-intercepts and y-intercepts are both the origin. All right, now this one goes up the hill first and then down the hill. So we are at increasing interval negative infinity to 0 and decreasing 0 to infinity. Okay, symmetry, y-axis because it's even. Discontinuities, there are none. And now we have a negative even in behavior. So instead of putting up on the left and up on the right, we should be putting down and down. All right, so as x approaches infinity, y approaches negative infinity, f of x approaches negative infinity, and as x approaches negative infinity, f of x also approaches negative infinity. Okay? That's it for lesson 1.